This video is about resistance and Ohm's law. It corresponds to section 4.3 of the Applied Analog Electronics textbook. Now, resistance is a property of components. So if we have a component with two ports on it, that is two nodes that it's connected to, A and B, we will have the voltage across it, VAB, and a current through it. And if we plot one against the other, let's put the voltage here on the y-axis and the current on the x-axis. It'll go through 0, 0. When we have no voltage, we'll have no current. We're always going to go through 0, 0. But there are various curves we could get as a result of this component. And different components have different sorts of characteristics. One that we might have, for instance, could be something where the voltage goes up very rapidly with current and then kind of levels off. And that is basically what a diode does. Actually, make it more clear, the diode continues having zero current at negative voltage. Another component that we'll deal with is something where this will go up sort of linearly for a while and then tend to saturate. And we'll see that for things like transistors. There is one very special sort of component where we have a straight line through 0. Okay, so for all these components we have a common property, and that is we can look at the slope of the line, the derivative of the voltage with respect to the current. And that is called the dynamic resistance. And it's dynamic because it'll change for different points on the curve. The slope of the line here is different depending on what the current is. Slope of the line here changes depending on what the current is. Under the special case that we have just a straight line for our component, then we talk about it as just resistance. And notice that this straight line here has got a slope. It goes through 0, so we could write the formula for it as V equals I times R. And that is Ohm's law. It's an empirical observation that some materials, some components, have this straight line property that current and the voltage are linearly related, and the slope of that line, so what you multiply the current by to get the voltage, is called the resistance. This was originally, I believe, observed by Ohm, which is why Ohm's law is named after him. And it is an empirical observation. It's not something theoretical. It was observed initially in metals, but it also applies to a few other materials. The resistance unit is written with capital Omega. It's called ohms. And 1 ohm is 1 volt divided by 1 amp. There is a common tendency for people doing electronics to want to plot current versus voltage. And when you plot it, the axes swapped like this, then the dI dV is called conductance, and it's the slope there is 1 over the resistance. The units for that, capital S, and it stands for Siemens. We will be, for the most part in this class, working with resistance rather than conductance, and working with ohms rather than Siemens. But despite that, we're often going to be plotting our characteristic functions for components as I versus V plots. They're more traditional, and they're a little bit easier to think about sometimes, because the way we create these plots usually is to put a voltage across a component and measure the current. And so one thinks then of the voltage as the independent variable and the current as the dependent variable. So that's why the I versus V plot is the common one, even though we usually think of the resistance rather than the conductance. And that's probably enough for now on resistance and Ohm's law.